life. Okay, so here's a situation. Okay, so you're in a burning floor, you're in a burning building. You have two choices. Someone above you dropped a rope and from up here and say, hey, come up here, come up, just climb the rope. So you have a choice. Should you go up, and then you also have a rope that you can toss out the window, then you can also go down. So let's take a look at the FBD of going up, and then we'll take a look at the one going down. All right, so let's take a look at the one going up first. So if you decide to go upwards and you're moving up, what kind of force is that? The force of motion. Net force. Right? Whenever there is motion or potential motion, that is what you label as the net force. And that will help you determine the free body equation. Okay? And if you decide to hold on to that rope and your weight is now hanging onto the rope, that would be called what? Tension force, of course, right? You're holding onto the rope. Every time you hold onto a rope, you have tension force. And of course, your mass is going to be pulled by the earth. We call that gravity. So these are the forces acting on your body on the way up. Okay? So let's write the free body equation now. So this is always the positive, which make that positive, which makes Fg negative. Right? You got that? Okay, so let's write down the equation. Can you guys do that right away? It shouldn't take long. So if you've done it already, great. If you haven't, take 5 seconds. Give me the equation right now for the FBD.
FBD would be F net force plus equals Ft minus Fg.
Okay? Is that equal to 0? No, it's not, because you're actually moving, you're climbing up. You are climbing up. Okay? That's what tells you right there, you're climbing up. Okay, so let's calculate the Ft in this situation where you're going up. So Ft is equal to net force plus Fg. That's our FBD equation. So hold on to that, and then let's take a look at the one if you decide to go down. If you decide to go down and hold on to that rope, you still have to be supported by that rope. You still have to have tension on that rope.
Yeah.
That Ft is going to be pointing up regardless of whether you're going up or going down that rope. Okay? All right, so this is now your net force because you're climbing down.
Yeah.
So let's take a look at the free body equation of this going down part. Net force is equal to
Ft minus
Fg minus Ft, because down is positive now and up it would be the opposite, right? So let's isolate the Ft here. It's negative. I don't like negative. I'm going to make it into a positive, put it over to the left. This will be Fg minus net force. That is the equation that you have. Okay, so let's say now, let's give it some numbers so we can actually come up with some numbers to compare. What mass did I give you? Okay, so 75 kilograms, right? And I said use a G of 10. So your Fg, we just said 750. Okay, so if you were to now take a look here, and A is, say, unknown, then you're gonna just say net force, which is Ma, plus this is 750. That will be the tension. Okay, and here the tension will be Fg, which is 750 minus Ma. Look at that. So if you were to increase your acceleration and you go up fast, look what happens. If you increase your A, that will increase your tension force.
Yeah.
Right? Does that make sense?
Yeah.
So if you're climbing up a rope, how would you climb up a rope? You want to go slowly. You want to carefully. You actually want your acceleration to be close to 0.
Yeah.
That means you're going to move slowly, very low acceleration or acceleration of 0, which you can't do. Right? As close to 0 as possible, which you can't do. So maybe 0.1.
Yeah.
Okay, as close to 0 as possible. So when you're climbing up a rope, go slow. When you're going down, okay, as A increases, the tension force decreases. So when you're going down a rope, you want to go fast. You know why? You want your acceleration to be as close to G as possible.
Yes.
And that is why
Quite G though, because
you can. That's called free fall.
yes.
Now, G would be 9.8, right? So if you actually let go of the rope, you'll just fall down. You have zero tension force on that rope. It will never break. But if you want to just, make that rope support your body, you want to get as close as possible to 9.8 by just really sliding down as fast as you can. So save your life, take the rope, go down as fast as you can. And you can see this when people are wall climbing. So if you actually ever go wall climbing or rock climbing, when you're using a rope to climb up, they go slowly and steady, slow and steady when you're going up. But then when they go down, they're going down so fast. And you know what? They're also using the wall. They're actually stepping on the wall and doing that gradually. Yeah. There you go. Physics saves lives.